Hi there, I'm Rishikeshwani, and today I'm going to explain the topic circular convolution and its methods. So let's start. So these are the contents of the PowerPoint presentation. So first is introduction. So what is basically circular convolution we are going to see. After that, what are the methods of the circular convolution? So as I talked, the first method is concentric circular method and example based on the method. Okay. And the second method is matrix multiplication method and the example based on that matrix method. And the last point is difference between linear and circular convolution. So this point is important because we have linear convolution before the circular convolution. So why we are going towards the circular convolution, that we are going to see in this point. Okay, so let's move forward. So what is introduction? Okay, so basically in the introduction part we are going to see what is circular convolution. So circular convolution is also known as cyclic convolution. Okay, and the basic definition of the circular convolution is the fundamental operation to compute discrete time sequence. So basically here we are computing or doing some operations on the discrete time sequence. So as you can see on the screen, x1 of k equals to summation of n varying from 0 to capital N minus 1 x of 1 of n into e to the power some constant term. Okay, that exponential raised to the power is being a constant. So and k varying from 0 to n minus 1. Also similarly, x2 of k is equal to n varying from 0 to capital N minus 1 x2 of n into e to the power, that same term, and which is constant. Okay, so don't bother about that. So what are these x1 and x2? These are the two sequences which we are going to take to calculate the circular convolution. Okay, so these are the two sequences which are giving us a signal, a continuous signal, because these terms are x1 of k and x1 of n is the discrete time sequence, but x1 of k are their respective DFTs. Means a capital X1 of k is the DFT of x1 of n, and x2 of k is DFT of x2 of n. So here we take x3 of k equals to x1 of k into x2 of k, and as I told earlier, x3 of k is DFT. So what is DFT? DFT is discrete Fourier transform. So x3 of k is discrete Fourier transform of the sequence x3 of n. So how we can obtain x3 of n? As you can see below, x3 of n can be obtained by this formula, m varying from 0 to capital N minus 1 x1 of m into x2 in the bracket n minus m into n of n. Okay, and m varying from 0 to n minus 1. Here n is capital N is nothing but the period of the sequence. So the period can be 2, 3, 4, 5 or 6. So this is the basic thing. So now we are going to see what are the methods or what are the techniques of the circular convolution. So first technique is concentric circular convolution method and matrix circular convolution method. So let's go forward and see the first technique. So the first technique is concentric circular convolution. To calculate circular convolution using this method, we have to follow certain steps, and if we miss any of the step in between, so the answer we get, it might be wrong. So listen carefully and note down the steps. Okay, so firstly we have to consider two sequences, x1 of n and x2 of n, and we are going to see the steps to calculate the circular convolution. So first step is consider two concentric circles and plot capital N samples of x1 of n on the circumference of the outer circle. Here one condition is mandatory, which is maintaining equal distance in successive points. So we have to maintain equal distance while we plotting those points on the circle. Okay, in anti-clockwise direction. Anti-clockwise direction is very important in this case because we are considering that signals as positive. Okay, second, to plot x2 of n plot capital N samples of x2 of n in clockwise direction. Here we reverse the direction on the inner circle because we are considering that circle in the inner side of that x1 of n circle. Okay, and starting sample placed at the same point as of the x1 of n. So we have to start that direction or that sequence from the same point. Multiply equivalent samples on the two circles and add them to get output. Rotate the inner circle in anti-clockwise direction with one sample at a time. Or we can do one thing. I'll explain in that thing in next slide. Okay. So what we can do, I took here one sequence and plotted in this way: x1 of 0, x1 of n, x2 of n, x3 of n, and the second sequence has x2 of n, x2 of 0, x2 of 1, x2 of 2, x2 of 3. And what I am going to do, I am going to obtain another sequence which is x3 of n, and which can be obtained by m equals to summation of m equals to 0, m varying from 0 to 3, x1 of m into x2 of n. And I have to put the values of n varying from 0 to n minus 1. Here capital N is 4 because there are 4 signals. That's why n minus 1 is 3. So that's why the summation is varying from 0 to 3. Okay. So as you can see, I have obtained here one circle, and I am obtained that circle by multiplying the corresponding numbers and adding them at the last. So we have to perform these at 4 times because the values of n are varying from 0, 1, 2 and 3. Okay, and we get those 4 values and plot them in one sequence. So we got the circular convolution of that sequence. So let's move forward. The second method is matrix circular convolution. So what is this method? So in this method we are considering again two sequences which are x1 of n and x2 of n in the matrix form. So what we are going to do now, so one of the sequences will be repeated via circular shift of the one sample at a time to form a n cross n matrix. Other sequence will be represented as column matrix. Multiplication of those two sequences of those two matrices gives us the result of the circular convolution. So you might get a clear idea, but to make it more clear, let's move forward and let's see. So here what I do, I consider these two sequences and this is one matrix. So how I am going to manage this. So I wrote here x1 of 0, x1 of 1, x1 of 2, x1 of 3. So what is the next column? The next column is let's move that x1 of 0 here, x1 of 1 here, x2 of 1 here, and x1 of 3 here. So in this way we are going to prepare a 4x4 matrix because there are 4 elements. So this matrix is going to be 4x4 and this matrix is going to be 4 cross 1 because the sequence we are going to put in this format, and after you multiply these two matrices you are getting a result of 4 cross 1 matrix, and that sequence is nothing but the circular convolution using matrix method. You can compare this answer with the answer you get earlier using concentric circle or circular convolution using that graphical method. Okay, so this is about that this is about the matrix method.
So after that the next slide is difference slide. So the difference between,
so what is the difference between the linear convolution and the circular convolution? So first point is shifting. So there is linear shifting in linear convolution and there is circular shifting in circular convolution. As I tell earlier, if you remember that circle, so that is circular shifting. Okay, so samples in the convolution result. So what are the samples in the convolution results? The result we are getting in linear convolution is in the form of n1 plus n2 minus n, because means the total number of samples are, if you take the example, there are 4 samples in first sequence, 4 samples in second sequence, that makes 4 plus 4 8 and minus 1, which gives me 7. So there are 7 samples. Okay, so in the convolution result, but in circular convolution that is not the case. If we took both sequences 4, 4, so both are the same, so there are going to be only 4 samples. Finding response of a filter. So in linear convolution, without doing anything, the response of the filter can be found out. But in the circular convolution, if we are going to find the response of the filter, so we have to pad 0. Okay, so what is meant by pad 0? If there is one condition that we have to make the length of two sequences same, that's why we have to pad zeros. Means we have to add the zeros in that sequence, because it doesn't do anything to that sequence, but it equals the length of that sequence. So that's all about the circular convolution. Thank you.